guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at disguised quadratics. So without any other delay, let us begin. So before I begin the video, I would like, if you are not comfortable in solving quadratic equations or factorizing quadratic equations, you can watch my previous video on solving and factorizing quadratic equations, because in this video we will be solving quadratic equations and factorizing them. Now, how exactly does a disguised quadratic equation look like? To begin with, we know that that a normal regular quadratic equation is something like this: ax squared plus bx plus c, where a, b, and c, where a and b are the coefficients of x squared and x respectively, and c is the term that has no x attached to it. It's independent of x. Now, in a regular quadratic equation, you would have generally your x, there would be one x raised to the power of 2, one x raised to the power of 1. You know it's raised to the power of 1, it's just that we don't put the 1 there, so it's just x, and one term independent of x. In a disguised quadratic, most of the times you might see something like this. For example, a to the power of 6 plus b to the power of bx to the power of 3 plus c. And instead of a, let's say this is x to the power of 6 plus bx to the power of 3 plus c. And now you would say that, okay, yes, it's not a quadratic equation yet because you don't have an x squared and you don't have an x, but in order to deal with disguised quadratics, it's all about how you can rearrange the equation and drive it back into this format. So for example, for this one, we can express this instead like this: x to the power of 3 all squared plus bx to the power of 3, bx to the power of 3 plus c. And we know that x to the power of 3 all to the power of 2 is the same as x to the power of 6 using your law of indices, because 3 would multiply by 2. And now what we can do is we can simply say, let's x to the power of 3 equal to p, or any other constant, equal to y, equal to z, equal to a. I'm just using p because I like it. So let x to the power of 3 equal p, and then you can insert this p over here and this p over here and make it now p squared plus bp plus c, where c obviously will be a number, they would give it to you, and x would also be the coefficient which they would give it to you. And now you can see that you have it back in the form of a quadratic equation. However, once you do get your final values for p, the two values for p, or the one value for p if it's a repeated root, you need to remember that you let it represent something. So whatever your value for p is, let's say for example you got 2, so you would now, one of the values you got was 2, so you would now do 2 is equal to x cubed, and then you would solve for x, so x would now be the cube root of 2 plus minus. So that's a basic overview of how disguised quadratics look like. This is a topic that's much better understood when we do examples, so let's go right ahead and dive into the first example. Right, the first example says, find the real roots of the equation 4x to the power of 4 plus 3x squared minus 1 equals 0. Now when it says real roots, all it's saying is for you to find the true values of x, the values of x that satisfy this expression. So we have 4x to the power of 4 plus 3x squared minus 1 equals 0. Now we can rewrite this as something like this: 4 into x squared, and that to the power of 2, plus 3x squared minus 1 equals to 0. And to confirm, that if you expand this, this would give you x to the power of 4. So 4x to the power of 4, because this 2 would multiply by this 2. So now that you have that, you can now say let x squared be equal to your chosen constant, and let's say p again. So you would now have 4p squared plus 3p minus 1 equals 0. So whatever was x squared, I just left p over there. So I put p into x squared here, and I put p into x squared over here. Now from here, all you have to do is simply solve it quadratically. So this would be 4p squared plus 4 here plus 4p minus p minus 1 equals 0. This can be factorized to 4p into p plus 1 minus 1 into p plus 1 equals 0. This would then be 4, this would be 4p minus 1 and then p plus 1 equals 0, and then you know that p is equal to 1 over 4, or p is equal to minus 1. So what I did, I just equated these two equations separately, 0 and solved for p. Now that we have our two values for p, this is not the final part of the question, because we want to find the real roots of the equation 4x to the power of 4 plus 3x minus 1. The roots are x, so we need to solve for x, not p. And if you remembered, we said let x squared equal to p. So for the two values of p we got, we would just equate it to x squared now. So for the first one, for this one, we would have x squared equals to 1 over 4. X would be the square root of 1 over 4, and that is 1 over 2, plus minus 1 over 2, because it is a root. So that's one answer, and that's two answers in a way, because positive 1 over 2 and minus 1 over 2. And the other one, we have x squared equals to minus 1, and then you take x is the root of minus 1. However, we know that if you take the square root of a negative, you will not get a real value. So henceforth, this cannot be done, and the only answers that we have is x is equal to 1 over 2 comma minus 1 over 2, and those are the two answers you have. Just to be sure, you can input both these values into the equation over here, and you should get equal to 0. Just to be on the safe side, you can always do that. So on to the next example. Okay, this one says solve the equation x to the power of 6 plus 26x cubed minus 27 equals to 0. So x to the power of 6 plus 26x cubed minus 27 equals 0. I can rewrite this as x to the power of 3 squared plus 26x power 3 minus 27 equals 0, because you know that this, if you open up, would give you x to the power of 6 as normal. So now again we can say let's x power of 3 this time equal to p. You would have p squared plus 26p minus 27 equals 0. So again, we use our factorization skills to solve this. This would be p squared plus that should be 27p plus 27p minus p minus 27 equals 0. We can rewrite this as p into p plus 27 minus 1 into p plus 27 equals 0. We can now write this as p minus 1 and p plus 27 equals to 0. So we have p is 1 or p is equal to minus 27. Now again, this is not the final answer because we let x cubed be p, so we solve for x. So x cubed is equal to 1. X is the cube root of 1 plus minus. X is equal to 1. That's one answer. And the other one is x cube is equal to the is equal to minus 27. Then x is equal to the cube root of minus 27, and in this case x is minus 3. Now you may be wondering why I did not write plus minus 1 here. The reason is because if you put minus 1 back into the equation here, it will not give you 0. It's only 1 that will satisfy it, and likewise for this one over here too, it's only minus 3 that will satisfy it. So that's why it's always a good idea to check the x values you got back into the original equation to see if it's satisfying or not. And that's the answer for that one. On to the next example. Right, this one says solve the equation 2x minus 7x to the power of 1 over 2 plus 3 equals to 0. So this time they're giving us the power in the form of a fraction rather than a whole number. So we have 2x minus 7x to the power of 1 over 2 plus 3 equals 0. Now we can rewrite this as 2 with this x to the power of 1 over 2 into 2 minus 7x to the power of 1 over 2 plus 3 equals 0. Now you know that this, if you expand, is simply x, because 1 over 2 times 2 is 1, and that's what you have here, 2x is to the power of 1. So now again we can say let x to the power of 1 over 2 be equal to p. You will now have 2p squared minus 7p plus 3 equals to 0. So again, we use our factorization skills. This is 2p squared minus p minus 6p plus 3 equals 0. This will be 2, wait, no, not 2, will be p into 2p minus 1, and then minus 3 into 2p minus 1 equals 0. And you can write this now as p minus 3 and 2p minus 1 equals to 0. And from this we know that p is 3 or p is 1 over 2. Again, know your final value because you let x be represented, you let p be represented to something. So now we equate that to these two values. We would have x to the power of 1 over 2 equal 3. Square both sides, you would have x is equal to 9. And for the other side, you would now have x to the power of 1 over 2 equal 1 over 2, yeah. Square both sides, x would be 1 over 4. And again, if you put these two values back into the original equation, they will satisfy the expression. Hence, these two are the correct values for that question. And on to the final example for this video. And this is a challenge question. So please do pause the video and have a go at this by yourself, and then resume the video to see if you're correct or incorrect. If you are incorrect, do take note of your mistake. Right, it says solve the equation x minus 6x to the power 1 over 2 plus 2 equals 0, giving your answers in the form p plus minus q roots r, where p, q, and r are integers. Okay, good to know. So we have our equation. So first things first, from the question rather, I can derive that once I have my quadratic equation, it's not going to be factorizable, because the hint is given over here. They said that your answer is in the form of a root. So that means we'll most likely complete the square to find the final answer. So we'll get there actually, we'll get there eventually. So let's do this first. We have x minus 6x to the power of 1 over 2 plus 2 equals 0. So rewriting this, I can have x to the power of 1 over 2 squared minus 6x to the power of 1 over 2 plus 2 equals 0. Again, we know that this is simply 2 times 1 over 2, which is x to the power of 1, and that's what we had over here, so it's the same thing. Now we can say that x to the power of 1 over 2 equal p. Just rewrite that. 1 over 2 equal p. So we would now have p squared minus 6p plus 2 equals 0. Now, as I said, this is not factorizable because the question said that in the form of a root. So the best way to go about this is to complete the square. If you're not comfortable in completing the square, you can watch my previous video on one of my previous videos, which was on completing the square. So to complete the square, we know this would be p minus 3 squared minus 3 squared plus 2 equals 0. This p minus 3 squared minus 9 plus 2 equals 0. This is p minus 3 squared minus 7 equals 0. Take the 7 to the other side. We would have p minus 3 squared equals to 7. Takes the square root of both sides. We have p minus 3 equals to plus minus root 7. And take the 3 to the other side, would have p equals to plus minus root 7 plus 3. So for our p, we have two values. We have positive root 7 plus 3, and we have minus root 7 plus 3. Now, again, remember, we represented something with p, and it was x to the power of 1 over 2. So let's take one of them. Let's say x to the power of 1 over 2 is equal to 3 plus root 7. Let's take the positive first. Square both sides. You would have x equals to 3 plus root 7 squared. This is the same as x equals to 16 plus 6 root 7. And if we do x to the power of 1 over 2 equals to 3 minus root 7, we will now, squaring both sides, have x equals to 3 minus root 7 all squared, and we'll have x equals to the same thing, just that the sign will change. This is plus here, it would now become minus 6 root 7. So you can actually save a lot of time by not expanding all this again, by just changing the sign from plus to minus over here. And that is the answer, the two final answers to that question, and that indeed brings us to the end of this video. So thank you for watching. Hopefully you guys will enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe, and thank you for watching, guys. Have a nice one.